Most developers make the same mistake when they get a new set of requirements. They open their IDE and start typing. But without a plan, you're just writing future technical debt. Today, we're taking a dorm management system from raw requirements to a professional architecture in 4 clear steps. So you never have to wonder, where do I start again? Let's start by looking at the requirements of the software we're asked to build. The idea is simple. We have a dorm with multiple floors and multiple rooms on each floor. We have shared laundry machines that residents can book. Residents can book cleaning services at a certain hour on a specific day. They can ask for maintenance if something goes wrong. They can request 2 internet cards, credentials per month. The dorm owner collects cash payments only, but he wants to log those payments in the system. The first step is identifying the architectural characteristics we should focus on. Architectural characteristics are properties such as scalability, security, performance, agility, and more. We don't need to focus on all of them. No software can maximize all characteristics at the same time. For example, maximizing security often reduces usability, since additional security measures can make an application harder to use and navigate. Instead, we should focus on the top 3 architectural characteristics the business cannot operate without. This doesn't mean we ignore the others. It means we don't invest extra effort to maximize them. If security isn't in our top 3, it doesn't mean we remove authentication and authorization. It simply means we avoid adding advanced or extra security layers beyond what is necessary. Check the top 3 I chose for our dorm management system and let me know in the comments if you choose something else. The first one, data consistency. The guarantee that the data seen by all users is accurate, up to date, and follows strict business rules. No contradictions. This is important because the whole purpose of the software is to reduce real-world conflict and manual hassle of managing all resources in the dorm. So for example, if resident A and resident B both open the app and see the washing machine is free at 5 p.m. and the system allows both to book it, you have created a physical conflict in the real world. This might lead the dorm owner to roll back to doing things manually and getting rid of the software. The extra effort we might put here is, for example, pessimistic locking or database level exclusion constraints to ensure that once a booking process starts, the time slot is physically locked until the transaction is complete. You see how we start thinking of maximizing this property of the system and invest extra effort into it? We won't do that for all the other properties. We only do that for the top 3. The second one is security. Ensuring users can strictly access only the data they are permitted to see. Multi-tenancy logic. This is a dorm where people live. If a bug allows resident A to view resident B's payment history, financial data, or maintenance requests, potentially sensitive photos of their dorm, you face immediate loss of trust and potentially legal liability. Extra effort we might put here is implementing row-level security in the database or a robust attribute-based access control layer in the backend. This ensures that even if a developer makes a mistake in the UI code, the database physically refuses to return data that belongs to another resident. And the last one is auditability. The ability to reconstruct the history of the system state and prove who did what and when. Let's say a resident claims, I gave you $500 cash for rent last Tuesday. The admin says, no, you didn't. If the system only shows the current status, which is unpaid, you cannot solve this dispute. You need a log showing if the admin marked it as paid and then accidentally reverted it, or if it was never entered. An extra effort we might implement is event sourcing or a comprehensive audit log table that is append only. Every time a payment status changes, a booking is rescheduled or a request is rejected. We record timestamp, actor, user ID, old value, new value, and reason. Now here's what we will not over-engineer. Number 1, scalability. The dorm has a fixed number of rooms. The user base will not suddenly jump from 500 to 5 million overnight. Number 2, high availability. 99.999% uptime. If the system goes down for 2 hours, residents can wait to book their laundry. The business doesn't lose millions of dollars per minute like Amazon would. Number 3, performance, microsecond latency. It is acceptable if page loads in 800 milliseconds instead of 50 milliseconds. Now, if this was a SaaS product for a company that wants to sign DOMs all over the world, different considerations could have been made. Don't over-engineer for this while no one asked for it yet. The second step is choosing our architectural style. The main architectural styles are layered architecture, modular monolith, microkernel, microservices, and event-driven architecture. Now, I can't explain each one of these in this video because that would take too long. If you're interested in having a video comparing all five, tell me in the comments below. However, I'll show you how to choose the right one here. We start by listing the top 3 architectural characteristics we selected in the previous step and comparing them across the 5 styles. Take a look at the following matrix, which uses a 5-star rating system for our dorm management software. As you can see here, the rows represent the 5 architectural styles. The columns represent the characteristics. And I added one more column to indicate overall complexity, which we will consider given our team size, budget, and time constraints. Let's take an example from the matrix to make the idea clearer. Auditability in microservices is more challenging because we have multiple services, each with its own logs, and having a centralized logging system is not straightforward. There is a solution, but it adds complexity. Based on this analysis, I chose the modular monolith as the architectural style. It maximizes our top 3 architectural characteristics, as you can see here. If you're interested in learning how to apply this style, let me know in the comments also so I can create a dedicated video about it. The third step is the most interesting one for me. It's the logical components split. I will show you how to do the exercise to organize your app in a maintainable way that is easy to change and understand. The goal of this exercise is to reach a structure we can follow in our packages, files, and logic split. We're going to follow a well-known approach here called workflow approach. Let me demonstrate it through our DOM management system example. First, we identify the big categories as our logical components based on our hunch and intuition. This is our starting point. So here we have dorm structure, payment, room cleaning, laundry booking, internet cards, and maintenance. Then we assign each user story to its own bucket. It now looks like this. Second, we evaluate each bucket, logical component, and check if it's manageable or handling too many responsibilities. It's clear here that all the logical components are big and not manageable. That's why we're going to split them into sub-buckets, sub-logical components. For example, in the dorm structure component, the admin will follow this workflow. Create floors, then create rooms, then assign residents to rooms, then view all assignments. So here we can split this into 2 main sub-buckets. Facility, which is responsible for managing floors and rooms, and tenancy, which is responsible for assigning residents and viewing them. And we do the same for all other requirements. This can be done for as many iterations as we want until we're comfortable with the structure. So as you can see here, we did another iteration and dorm structure became like this. It's now called accommodation instead of dorm structure. It still has facility and tenancy, but inside of tenancy, we have view and assignment as sub-buckets. View is responsible for viewing all residents and their room assignments. Assignment is responsible for assigning residents to rooms. Now, this looks manageable and clear enough. For the full exercise, I will attach it in the description below. Now we're almost done, but there's one last step you should know about and keep applying as you work on the system. The fourth step is architectural decisions and architectural decision records, ADRs. As you're working on this app, you will have to take many architectural decisions. Examples from our dorm management system are both laundry and room cleaning involve booking a slot. The question is, should we build a single generic booking component that both services use or keep them as separate laundry and cleaning components? Residents attach images to maintenance requests. So the question is, where do we physically store these images? How do we create a financial audit trail, event sourcing, or a comprehensive audit log table that is append only? What database type are we going to save the data in? And so on and so forth. For each of these decisions, we should do the following. Lay out our options, keep the top 3 architectural characteristics in mind, then choose the one we're going to follow. And most importantly is documenting this process. We often think we remember why we did something, but future you will inevitably forget. This is where an architectural decision record comes into play. For each decision, we create a document with the following format. Title, this should be numbered. It should clearly indicate what's the topic. Example 001, generic versus specific booking component. Then we state what is the problem and context. A brief explanation of what you were trying to solve and what constraints you were facing at the time. Example, both laundry and room cleaning require slot booking. We must decide whether to implement one generic booking component or 2 separate components, laundry booking and cleaning booking. We want the decision to optimize for these architectural characteristics: data consistency, auditability, and security. So we create this comparison matrix based on the three characteristics. The first column is the option, generic or separate components, and then the following three columns are data consistency, auditability, and security. So as you can see, for the generic booking component, the three characteristics are strong, while for the separate components, it's medium. Then we write the solution, exactly what you decide to do and why it was the winner over the other options. Example, we decided to build a single generic booking component that both services use, with service-specific extensions config. Why this wins on the three characteristics: data consistency, one canonical implementation for slot availability, conflict prevention, and booking creation, fewer diversions bugs. Second, auditability, one consistent audit schema for slot viewed, reserved, booked, cancelled, updated events, easier investigations. And finally, security, one centralized authorization plus input validation path, fewer places to forget a permission check or validation rule. And finally, you write the accepted trade-offs. What are the downsides or non-ideal consequences of this choice that you are willing to live with? Example, the generic component can get fat if service differences grow. It may require extension points, config, hooks, which adds design effort. If laundry and cleaning diverge heavily later, we may need to split them. We accept this because today both flows are essentially the same, and the centralization directly supports consistency, auditability, and security. Now you're set and ready to start building with a confident plan, and you will document each decision taken in the system so that it's easy to remember why you took those decisions and explain them to newcomers.